Hello Year 9, this is your lesson on substitution, more specifically solving simultaneous equations using substitution. So last lesson we looked at solving simultaneous equations by drawing graphs, and this can take a long time, particularly if you don't have your CAS, and it can be imprecise when the solutions aren't nice easy numbers like integers or simple decimals. What we're going to be looking at over the next few lessons are two algebraic methods for solving simultaneous equations, and the first one that we'll be looking at today is by substitution. So here's our first example. Now you'll see that these equations have been labelled with numbers. It's a good idea to do that so you can refer to them easily. I put the numbers in circles, circles brackets, just so you don't get these numbers mixed up with the numbers in the equations. So when you're showing your working in your exercise book, it's really important that you write these equations down. So this is my equation 1. This is my equation 2. Now, very conveniently, both of these equations have y as the subject. If y is equal to both of these expressions in x, then what I can do is set these two expressions equal to each other. So I know that 2x plus 1 equals y, and 3x minus 2 equals y, so they must be equal to one another. Then this is just a linear equation with the pronumeral on both sides. So my first step is going to be to collect all of the x's on one side. I could subtract 3x or I could subtract 2x. Subtracting the smaller amount of x's makes things easier for me. So I'm going to subtract 2x from both sides. And then I'm going to add 2 to both sides. So this is my solution for x, but when I'm solving simultaneous equations, I need to solve for both pronumerals, so I need to find y. To do that, I'm going to substitute into the first equation. So 2x plus 1, 2 times 3 plus 1, so that's 6 plus 1, which is 7, and that's my y. But I need to check. So check using the other equation, equation 2, 3 times 3 minus 2, so I've substituted x in. That gives me 9 minus 2, that equals 7, so I know I'm correct. Then because I've got quite a lot of working going on there, it's a good idea just to state your final solution. So x equals 3, y equals 7. Now, this method is called the substitution method because I'm replacing or substituting one of the pronumerals by an expression involving the other. So I'm using the fact that y is equal to 3x minus 2, substituting that into this equation here. Pause the video now while you have a go at question 1. As a bare minimum, I would like you to do these questions here. Okay, let's look at a second example. So I'm going to start by writing out my equations. Now here, they're not both equal to y, but this equation is equal to y. So I can take this expression in x and substitute it into this second equation for y. So you'll see, instead of y, I've written 2x minus 1. Then I just need to solve this equation. I'm going to start by expanding the brackets. Remember to multiply both terms inside the bracket by the thing on the outside. Then I can collect these like terms together. Subtract 2 from both sides and divide by 7. I found my solution for x, but I need to find my solution for y. I can substitute it into either of these. This one's going to be much easier. Then I need to check by substituting my values into equation 2. So I have 3 times 1 plus 2 times 3. 9 is 9, that's what I wanted. So I finish by stating my solutions clearly. Pause the video now where you have a go at question 2. And again, as a bare minimum, do these 4. Okay, so this is similar to before, just y is not the subject this time. But x is the subject here, so I can take this expression in y and substitute it into my second equation for x. Expand the brackets, be careful with the negative. Collect my like terms. Subtract 2 from both sides. If negative y is positive 10, I can multiply both sides by negative 1. Now I've found my solution for y, I still need to find my solution for x. I could substitute it into either one, but this one's going to be easier because the x is the subject. Be careful with your negative calculations here. So this is my value for x. I'm going to check with equation 2. Got lots of negatives again, so make sure I'm being careful. 3 times negative 10. Subtract 2 times negative 21. So that's negative 30, subtract negative 42. That equals 12, which is what I wanted, so that's correct. And so finally, state my solutions nice and clearly. Now, with solutions like this, they would be hard to guess. Sometimes you can just guess the solutions to simultaneous equations, but that's not properly solving them. And also drawing a graph, it's rare that you draw an x-axis all the way to negative 21. So these would be difficult to find if we didn't use an algebraic method. Pause the video now while you have a go at these ones. These are the minimum. Okay, so sometimes neither of the pronumerals will be the subject of the equation, but we can still use substitution. We just need to rearrange one of the equations to make one of the pronumerals the subject. So let's have a look at this example here. I'll start by writing out my equations. Now, I could rearrange either of these and I could choose to make X the subject or Y the subject. It doesn't matter. Sometimes one will be easier than another, but that won't always be the case. I'm going to choose to rearrange equation 1 because it has slightly smaller numbers, and I'm going to choose to make X the subject because that will mean I can add 2Y. So I'm going to make notes of what I'm doing. So I can add 2Y to both sides. And then I can divide by 3. Now, this is what I'm going to substitute into equation 2. That's not particularly nice, but I can still work with it. I'm going to start by expanding the brackets. Remember, when I'm multiplying fractions, I can think of a whole number as having a denominator of 1. Now, I don't like this denominator of 3, so I'm going to multiply everything by 3. 7y times 3 is 21y. My fraction, now I'm subtracting this whole thing, so it's minus 5 minus 10y. And then I need to remember to multiply this side by 3 as well. I can collect the like terms on my left-hand side. I can add 5 to both sides. And then I'm just going to have to go across here, and then I can divide by 11. Moving up to here, I found my y, so now I can substitute that to find the x. Neither of these will be easier than any other here particularly, so I'm just going to substitute it into 1. Then I'm going to check using 2. That's correct, so I can state my final solutions nice and clearly. So there's a few steps there, but as long as you set out your algebraic working step by step and nice and clearly, you'll be able to find the answer. Have a go at these 4 questions now, and let me know if you have any questions yourself. Thank you.